All right, so today we're looking at what happens when we have absolute value equations with fewer than two solutions. So you've seen that absolute value equations have two solutions when the isolated absolute value expression is equal to a positive number. When the absolute value is equal to 0, there's a single solution because 0 is its own opposite. When the absolute value expression is equal to a negative number, there's no solution because absolute value is never negative. So we want to solve these just as we did before. We need to isolate the absolute value expression in each equation to determine if it can be solved. So again, first step is always to isolate the absolute value and then go from there. So for here, we first subtract 2 from both sides, divide by -5. Then since we have an absolute value equal to a negative number, the answer is going to be no solution since absolute values are never negative. So starting from here, if we want to isolate this absolute value, the first thing we need to do is add 3 to both sides. So -3 plus 3 gets us to 0. When we multiply both sides by 5 over 3, anything times 0 is still going to be 0. When we rewrite it as one equation, again, 0 is its own opposite, so we're just going to have 2x minus 4 equals 0. Add the 4, divide to find that x equals 2. So that one has one solution. All right, working through a couple more examples here. Again, we want to isolate the absolute value and determine if it can be solved. So here on the left, the first thing we want to do, we want to subtract that 7. So 5 minus 7 is -2. Divide by that 3. So -2 divided by 3 will be -2/3. And from here, we can already see, okay, an absolute value can't be a negative number, so there is no solution. Over here on the right, so to isolate the isolate the absolute value, the first thing we would do is subtract that 7. Well, 7 minus 7 is 0. If we divide by that 9, we'll still be left with 4/3 x minus 2, and our absolute value is equal to 0. So we can take what's inside, set it equal to 0. We'll add the 2, multiply by our reciprocal, 3 over 4. Those multiplied to become 1. X will be equal to 6 over 4, which reduces to 3 over 2. So if we want to elaborate a little bit, why is it important to solve both equations in the disjunction arising from an absolute value equation? Why not just pick one and solve it, knowing the solution for the variable will work when plugged back into the equation? Well, the solution to a mathematical equation is not simply any value of the variable that makes the equation true. Supplying only one value that works in the equation implies that it is the only value that works, which is incorrect. So if we want to look at the range of the absolute value function and how it differs from the range of a linear function. So the range of a non-constant linear function is all real numbers. If I were to draw a linear function, a line, the range here, the possible y values we can have is going to be all real numbers because any value of y would work. Whereas the range of an absolute value function is y greater than or equal to k if it opens upward. So let's say we have an absolute value here. Our smallest y value here is k. So that's why our range would be y greater than or equal to k. It's all the values greater than k if it opens upward. And the y value is less than or equal to k if it opens downward. So because the graph of a linear function is a line, a horizontal line will intersect it only once. And because the graph of an absolute value function is a v, a horizontal line can intersect it once, twice, or not at all.